All right, so now we're 7-7, factoring special products. Now that we've looked at the difference of two squares and factoring a perfect square trinomial, let's do a couple examples using that to help solve an equation. Okay, so here first, in example 4, we're going to solve. This is different than our previous problems in that our previous problems weren't equations. They had no equal signs. This guy right here has no equal sign. This one has no equal sign. Okay, none of them had equal signs. We were just straight up factoring. Okay, but this one has an equal sign, equals 0. So, and it is a squared, which a bit of new vocabulary, we call that a quadratic, because quadratic is squared. Okay, so it's a type of polynomial that has an x squared in it, and that's the highest degree. So this is what we call a quadratic. That's just the name of it. Okay, and whenever you have an x to a power, okay, in an equation like this, you have to factor it first. Because the only way we can solve it right now is using the zero product property, and that involves I have a product, meaning I have to factor it first. I have to get those factors. Okay, very first, it has to be factored. So first thing is I have to factor this. Well, this one looks a little weird because of the fractions. Be like, oh man, I don't like those fractions. I'm going to need a common denominator to deal with those fractions. So I'm going to look at the denominators and decide what would the common denominator be. Between 3 and between 9, the common denominator, a number that both 3 and 9 go into, is 9. So 9 would be my common denominator. Instead of getting a common denominator for everything, we're going to do something called clearing the fractions. This only works when you have an equal sign, because you have to be able to multiply both sides of the equal sign by the same thing. So now I'm going to multiply both sides of this by that 9. So I'm going to take 9 times this side, x squared plus 2/3 x plus 1/9 equals, and then I'm going to take 9 times the other side, which is just a 0. So now I need to distribute this 9 in. So 9 times x is 9x squared. Then I need to take the 9 times the 2/3, which ends up giving me 9 times 2, 18/3, which is just 6, straight up 6, so 6x. And then 9 times 1/9 is just 1, equals 9 times 0 is 0. So what I've done is I've created what we call equivalent equations. Equations that are going to have the same solution, which is what we're trying to find is the solution, but that look different. Okay, and so this one has all kinds of messy, crazy fractions, but this one's nice. 9x squared plus 6x plus 1. And I'm noticing 9 is a perfect square, and so is 1. 9 is the square of 3. 1 is the square of 1. So I'm going to guess and check factoring this using that 3x. Because again, you have to factor it first. So we have to get this factored first to solve it. So I'm going to use 3x and 3x plus 1 and plus 1 equals 0. I need to check it. Make sure it worked. So distribute 3x times 3x, 9x to the second, plus 3x plus 1 times 3x, 3x plus 1. 9x squared plus 6x plus 1. Yep, it worked. Okay, so now I have it factored. I now have it a multiplication. That's a factor, that's a factor. So now I've set each factor equal to 0. Do not skip this step. I've seen a lot of people skipping this step. Do not do it. You need to take 3x plus 1 equals 0, or 3x plus 1 equals 0. Okay, now I solve each of these. Subtract 1 from both sides. 3x equals negative 1. Divide by the 3, x equals negative 1/3. Do the same thing on this side. X equals negative 1/3. So it looks like I've got a repeated root of negative 1/3. You really only have to list them once. So it looks like my solution is negative 1/3. To double check this, I'm going to go ahead and I'm going to bring up a graph. I'm going to bring up a calculator. Yeah. Okay, and we are going to graph it. Not graph it, we're just going to, okay, so I've got negative 1/3 and then squared plus 2/3 times negative 1/3. Oh no, sorry guys, lost it. Let's try again. It's easier doing it with keyboard. All right, so here we'll have negative 1/3 squared plus 2/3 times negative 1/3 plus 1/9, and we better get 0. Whew, it's 0, it worked. Okay, so we checked it again to make sure we put that negative 1/3 back up into our equation and we got it to work. All right, so very last example. Here we have a bird picks up a golf ball and drops it while flying. The function y equals 81 minus 16t squared represents the height y in feet of the golf ball t seconds after it is dropped. So y is the height in feet and t is the time. The ball hits the top of a 32-foot tall pine tree. Is that time or is that height? This right here is the height. So that would be a y, would be 32 feet. After how many seconds, we're trying to find after how many seconds does the ball hit the tree. So we're trying to, this is us, after how many seconds, we're trying to find t. So we're trying to find t that gives me a y of 32. And they give me an equation right here. So all I need to do is plug in the y of 32, 81 minus 16t squared, solve it for t. If you notice, this one is quadratic too. It's got a t squared. So I'm going to rewrite it the other way. And again, I need to factor it first. Well, to factor it first, it has to be set equal to 0. So I'm going to subtract the 32 from both sides. 81 minus 32 is 49. Okay. And now when looking at this, I can see both of these are squares. This is the square of 7. This is the square of 4. So I can use difference of squares pattern. I can use this pattern right here, difference of squares, to factor it, because to be able to solve it, you have to factor it. So this is going to factor into 7 plus 4t, 7 minus 4t equals 0. We need to check it. Distribute out. 7 times 7 is 49, minus 28t, plus 28t, minus 16t to the second. Those add to 0, 49 minus 16t squared. Yep, it worked. All right, so there I have it factored. So now I need to set each factor is equal to 0. 7 plus 4t equals 0, or 7 minus 4t equals 0. I'll subtract this 7 from both sides. 4t equals negative 7. Divide by my 4. Ooh, running out of room. T equals negative 7 over 4. Over here, I'm going to subtract this 7 from both sides, negative 4t. Divide by the negative 4 equals positive 7/4. So it looks like my two solutions are negative 7/4 and positive 7/4. But unlike our other problems, this has context. This is talking about, this is time. Well, negative 7/4 makes absolutely no sense in this context. Time of negative 7/4 makes no sense. So my time is 7/4. Time, we don't tend to like that as fractions, so I'm going to go ahead and we will 7 divided by 4, this was 1.75, and that wasn't approximately, we didn't round that, that was exactly 1.75, and time here is in seconds, so out of 1.75 seconds. Sure you label. So after 1.75 seconds, it hits the tree. All right, now your turn to get some practice in. Page 401, I want you to do 26 through 42 even.